Okay, good day. So this is Mrs. Tole. Today we are looking at trigonometry. This is the introduction to trigonometry. So I recommend this to grade 10s until actual 12. Okay. Now, so we're gonna start with what we call a Pythagoras theorem. Now, this theorem only applies to a right-angled triangle. Right-angled triangle. Now, what do we mean by that? A triangle with a 90 degrees, where one of the angles is 90 degrees, okay? Now, when you've got a triangle like this, the longest side, or should I say the side that is opposite to the 90 degrees, we call it hypotenuse, and that's the longest side. And if the adjacent, we have got adjacent side here and the opposite side, but now remember, it only, we name this according to the angle that we're referring to. So we are saying this side here is adjacent to this angle, and this side here is opposite to this angle. But when you're looking at alpha here, we are seeing that this side AB is now adjacent to the angle, and this one becomes the opposite. So we must always remember that. Now let's check here. Why do we need this? We need this to calculate size, okay, and also to calculate what you call angles. Now let's check here. We say hypotenuse squared is equals to opposite squared plus adjacent squared. That's the rule there. So it means that opposite squared, to get opposite squared, we're going to say hypotenuse squared minus adjacent squared, and adjacent squared, we get it by saying hypotenuse minus opposite squared. Okay. Now, these are the formulas that you must know, but also we are going to be dealing with sine, cos, and tan. So we need to know now on this triangle, how do we get sine theta? How do we get cosine theta? How does it relate? Now we know that sine theta is equal to opposite side over hypotenuse. So in this case here, we are looking at AB over hypotenuse, which is AC. But now I want to show you something here. When we say we are looking at sine alpha now, our opposite becomes it's still the same formula, opposite over hypotenuse, but in this case now our opposite is now BC over AC. So you just need to master when you're looking at an angle, which side is opposite to that angle, which side is adjacent to that angle. Now cosine theta, cos theta is equals to adjacent over hypotenuse, and tan theta is equals to opposite over adjacent. That's what we know there. Okay, these are the formulas that you must always know. Now, we are going to be talking about sine, cos, and everything. Now, on a Cartesian plane, the angle that you're going to deal with, like for example here, this is actually 0, then we've got 90 here, the right angle, then a straight line from this point here to this point is 180, this one is 270, this one is 360, the right round. Now, we find that all are positive. All, what do you mean all? Sine is positive, cos is positive, tan is positive. Okay, they are all positive, but only here we say all students take coffee. So all students take coffee. Now, what do you mean by this? Only sine here is positive. This only tan is positive, only cos is positive. Meaning to say here, sorry, I didn't see that. Now, it means here, apologies, here we are saying this side here, this on a Cartesian plane here, on this first quadrant, we call this the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. All of them are positive, meaning to say the angles below 90, between 0 and 90, all of them, if you punch cos 90, cos 40, cos 70, you find them as positive. But here only the angle above 90, if you punch it, only sign positive. For example, angle which is above 90 and below 180 is 120. Let's give an example, 120. If you say sine 120, you get a positive answer. But if you say cos 120, you get negative. If you say tan 120, you get also negative. That's what we are saying here. So we are saying here is negative, what you call the tan and cos. Here, only tan is positive, but sine and cos, they are negative. Only cos is positive, but sine and tan, they are negative. Okay, now let's move on to the next part here. We're just going to see if we understood here, just to see an example here. Now we are saying we want to find a hypotenuse, which is not there, x. So we know that x squared is equal to what you call 8 squared plus 6 squared. That's the hypotenuse. So now x is going to be root of what we get there. Let's see here, 8 squared plus 6 squared, 6 squared, we get 100. Now it's 100, so x is going to be root 100 is 10. So if we say root answer, we get 10 units. So our x is 10. Now if we are to look for sine theta, we say sine theta is equal to opposite 6 over 10. Okay, cos theta is equals to 8 over 10. Now, what about tan theta? Is going to be equals to 6 over 8. But now, let's check again. If we are to put alpha here, we will say sine alpha is going to be equals to 8 over 10. And cos alpha is going to be equals to 6 over 10. Why are we saying this? Because this side is opposite to the alpha. So you always have to check that. You always have to check that. Now, there are certain things that you know that you need to learn to punch your calculator. Like for example, here you are given that sine theta is equal to 0.34. Now they want theta. How do you get theta? Theta is going to be equals to arc sine of 0.34. Now you punch it, here. When you are punching it, you say shift sine, then you write 0.34, then you punch, you get your answer. This one will be at the angle 9.88. Always you leave your answer to decimal places. Now again, for cos, I want you guys to punch cos. For theta here, theta is going to be equals to arc cos of 0.91. Now what is it? Shift cos 0.91. What do we get? We get 24.49. 24.49. And don't forget to put degrees because that's how we measure it. Now, let's move on to what we call the reciprocals. Now, with the reciprocals, we are saying 1 over sine is cosec theta, 1 over cos is sec theta, 1 over tan is cot theta. Now, when we say cos 29 times sec 29, it means that we are saying cos 29 times 1 over cos 29. Then we'll cancel here, cross, it's going to give us 1. So this one is just for you to see. Now, so you must remember this. You must always remember this. Now, let's come here and see what we are having here. We are saying we have got a triangle here. And the triangle, what is given is a side and an angle. And the side that we're given is an hypotenuse. Now, we are asked to find FG. Where is FG? FG is here. But now we see that FG is opposite to the angle. But now, what do we know about this opposite angle? We know that sine, if we say sine 23, sine 23 is going to be equal to FG, which is our opposite, over 20. Now to get FG will make FG subject. FG is going to be equal cross multiply by 20, then FG is going to be equals 20 sine 23. Then what do we get there? If we are to punch that, 20 sine 23. What do we get? We get 7,8. 7,8. So we've got 7,8 That's what we get, units. What about G? We want to find the G. Now, this G, angle G, what do we know? We must know that interior angles, sum of interior angles of a triangle give us sum of interior angle of a triangle is 180. So what do we know? We know that if we say G, if we say our G plus our F, the angle of F, this represents an angle, plus our H must give us what? 180. And what are we looking? We're looking for G. So the G, we're gonna have to say is gonna be equal to 180 minus F minus H, which is gonna be equals 180 minus F. F is 90 minus what do we get? What do we have here? 23. Then what do we get? If we are to say that, we say 180 minus 90 minus 23, we get 67. So 67 is the angle. Now, what about, we want to calculate FH. FH, now FH, to calculate FH, there are many ways to do this, but now let's just use what call, we can use this, because we have the angle already, we can just say FH, we can use the same formula here, or we can use what Pythagoras theorem to say, if we are to say FH is gonna be equals to, because here we've got 7,81. We're gonna say it's gonna be equal to 20 squared minus 7,81 squared. And when we do that, what do we get? FH is going to be root of what we have here, 20 squared plus 7,81 squared, we get 460,9961. Root of that, we get 21,47 units. So this is one method that you can use, or you can say sine 67, the one that we got here, sine 67, which is this angle now that you have. Sine 67 is going to be equal to, what do we have here? Is going to be equal to FH over 20. And how do we get FH? FH is going to be equal to 20 sine 67. And what do we get here? When we say 20 sine 67, we get, what are we getting here? We're getting 18,41. Did you make a mistake there? 20 squared minus 7,81 squared, we get 339. My apologies, I made a mistake here. Instead of subtracting, I add. So it's 339,0039. Okay, so if we say root of that, we get 18,41. Now here, this is what the same answer that we are getting, 18,41 units. So these are different ways that you can use to calculate your side there. So you must always remember, even if it is a cos, you must remember that if you are given the angle in the side, check what the side am I given and which one can I use. Can I use tan? Can I use cos? Can I use actually sine? So it's up to you, and also the available information that is to you. Okay. Now let's move on here to, we spoke about what you call, I've indicated to you. Okay, I've indicated to you what our cosec, reciprocal cosec, sine. But now we know that sine theta is equal to y over r. What about cosec theta is going to be the inverse of that, so which is going to be r over y. And cos theta is equals to x over r. But what about sec theta is r over x. So now instead of saying adjacent, it's like opposite here, opposite over hypotenuse, it's going to say hypotenuse over opposite. That's what we're saying here. So let's say we're given the question here, and we know that r we don't have here. What must we do? We must first find that. And how do we get that? That one is our hypotenuse. So we know that r squared is going to be equals to 12 squared plus 9 squared. And when we do that, r is going to be equals to root of that. Now 12 squared, so if you say 12 squared plus 9 squared, what we get? 225. And what we get is an r, root of answer, we get 15. So now we have our 15 here. So now to calculate sec theta, we know that is hypotenuse. Hypotenuse is 15 over 9, which is our opposite, over 9. Simple like that. Then cosec is going to be equals to adjacent hypotenuse 15 over adjacent, which is 12. Then cot theta is going to be equal to cot theta is going to be equals to, instead of saying opposite over adjacent, we're going to say adjacent over opposite, 12 over 9. So that's what you must learn to do there. Okay, I hope you guys understood this. Now let's move on here and see what's happening here. Let's have like 3 sec theta is equals to 10. And I want to determine cos theta. We know that 3 sec theta is 3 times 1 over cos theta is equals to 10. Then we cross multiply with cos. Cos 3 is going to be equals to 10 cos theta. Then cos theta is going to be equals to 3 over 10. That's what we have there. That's our answer. Now, and here we are given that sine theta is equal to 3 over 5, but they want us to calculate, without using a calculator, they want us to calculate cos theta. What must you do? First of all, when you're given this, you must draw a table. You must draw a table. They use a sketch. You must draw what you call a sketch of a right angle triangle. Then you put the available information. You put an angle theta. Okay, then you say, all right, now how do I get my what you call my sine theta? We say opposite. We say it means that our opposite is this side. Our hypotenuse is 5. So now you want to calculate this side here. So this side here is our adjacent. Let's make it x. So you're going to say 5 squared minus 3 squared. What do we get? We get 16. Root of that. Root of 16, we get 4. So it means that our side here is 4. So we're going to say x squared is equals to 5 squared minus 3 squared, which you get 16, and x is going to be equal to root of 16, which is going to give us 4. So in other words, our x is 4. So now we have a complete table now with 4 as well here. That's what we are having here. And now what are you going to do to find cos theta? Cos theta, you're not just taking from the table now. That's what you're going to do. Cos theta is equal to adjacent over hypotenuse, which is equals to 4 over 5. Now, tan theta is equals to opposite over hypotenuse over adjacent, which is going opposite, which is 3 over 4. Then what about sec theta? Sec theta, we know that is equals to hypotenuse over adjacent, because this is cos. So we're going to say hypotenuse is 5 over 4. Then what about cosec theta? Cosec theta is equals to hypotenuse over opposite. What do we get? Hypotenuse over opposite, 5 over 3. That's what we get there. Okay, I hope you guys, you understand this and you also practice. Okay, so you must always remember the Pythagoras theorem. It plays a very important role in this. Now let's move on to this, what you call special angles. Special angles. These angles include 0, 90, 45, 60, and 90. You use this in cases where you are not supposed to use a calculator, because there are already values that are what you call for that. Like here, sine 30 is equal to sine 30 opposite over hypotenuse, 1 over 2. What about cos 30? Cos 30 is going to be equals to adjacent over hypotenuse, which is root 3 over 2. So even if you punch in your calculator, we say cos 30, we get root 3 over 2. So here is what you just need to remember this. You just need to remember the sine also 45. So for sine 45, we know that sine 45 is going to be equals to 1 opposite. You can see that it's 1 here. So 1 over root 2, which if you resolve, you get to root 2 over 2. So even if you punch here, say sine 45, root over 2, and cos 45, they are equal. They are equal to what called is equal. Cos 45 and sine 45 is the same. Okay. Now, then again, we've got cos 0 as well. We'll understand this later, but you must get the values here from the triangles. Okay. Then when you get the values of the triangles, when they say don't use a calculator, like if they say cos 30 multiplied by sine 45, what you need to do is just pick the values without using a calculator. There's no need for you to punch a calculator here. Cos 30 is root 3 over 2 times sine 45 is root 2 over 2. Then what do we have here? We multiply. When you multiply, it's going to be root of 3 times 2 is going to be root 6 over 2 times 3. 2 times 2 is going to give us 4. So that's what we have there. So you must always remember that. Now let's check a typical exam question here that I picked. Now we are saying given that 4 cot theta plus 3 is equal to 0 for angle 0 to 180. Okay. Use a sketch to determine the value of the following. Do not use a calculator. Calculate the value of cos theta, calculate the value of 3 sine theta, sec theta, and everything. But now, what must we do first? Use a sketch. So we know that 4 cot theta is equal to -3. And -3, we divide by 4 cot theta is equal to -3 over 4. And what do we do now when we come to what called, we draw our sketch. Our sketch now, we're going to draw is negative. So where tan, because this is 1 over tan, where tan is negative is on the second quadrant. So your triangle must be like this. So we are saying this is actually your theta, and we are saying here it's negative. We are saying this is 3. Remember, this is 3. Where is 3? Sorry. Opposite is 3. Then negative what? -4. -4 units here. That's what we have. Then to get the hypotenuse, which is r, we're going to say r is going to be equals to root of 3 squared plus -4 squared. What do we get there? We get root of 3 squared plus 4 squared, we get 5. So we are getting 5 here. So it means that r is 5. Now you've got all the sides now. You've got all the sides now, which is 5 here. Now to find the cos theta, you're going to say cos theta is equals to adjacent over hypotenuse. Now what is our adjacent? Our adjacent is -4. What about hypotenuse? 5. So you find that your sine also, your cos also is negative in the second quadrant. Then what about what is it? No. I think I made a mistake here. Just the mistake that is there is that here we have got, if it is cot, we know that this is adjacent, this one is opposite. So we are supposed to write -3 here, and here we write 4 here. Okay, that's what we're supposed to do there. So our opposite is actually 4, because remember we said cot is actually 1 over tan. So tan theta in this case is 4 over 3. -4 over 3. I hope you understand that. So here cos theta here is going to be adjacent, which is going to be -3 over 5. That's what we get there. Now, let's move on to this now. They are now saying 3 sine theta sec theta over tan theta. Now, what do we do now? We have this, so we just need to find here sine theta is equals to, sine theta is equal to opposite over hypotenuse, 4 over 5. What about sec theta? Sec theta is equals sec is 1 over cos. So if it is 1 over cos, we know that cos is 3 over negative 3 over, so it's going to be negative 5 over 3. What about tan theta? Tan theta is equals to negative 4 over 3. Then now we're just going to substitute here in our equation, not equation as such. Then expression 3, what about sine? What is sine theta? 4 over 5 times negative 5 over 3 all over negative 4 over 3. So you can punch this once in a calculator. You put your what you call 3 times 4 over 5. What do we get there? Times, put times negative 5 over 3. Okay, now what do we get there? Negative 4 over 3. Then what do we get? We get 3. So our answer, final answer, will be equal to 3. But now they are saying hence, show that sine squared theta minus 1 is going to be equal to sine squared, negative cos squared theta. Now, what do we do here? We come here and say, all right, negative sine squared theta minus 1 is equal to sine squared theta. What is our sine? Our sine squared theta is 4 over 5 squared minus 1. What do we get? We get 4 over 5 squared minus 1. We get negative 9 over 25. Then what about this is left hand side? What about right hand side? Right hand side, cos, negative cos squared theta. Now we're going to say negative. What is our cos? Our cos, we get cos negative 3. So you're going to put negative 3 over 5 squared. What do we get there? We're going to get negative 3 over 5. Okay. Squared, we get negative 9 over 25. So here is proven already. Okay, so here what must you master when you are given an equation like this, expression like this? You must always remember that you have to come up with a triangle. You have to come with, even if it was sine, even if it was cos, you must come up with a triangle. And this sketch is going to give you is a 90-degree, what you call a right angle triangle that you have to draw. Then you have to pick what is my opposite, what is my adjacent. So you get it correct from there. Okay. So I hope you guys understand what you call this introduction. Thank you so much for listening, and all the best in your exam. So for more classes like this, you must always contact us on our number. Okay, thank you so much.